I remember when the cardboard came out, you could watch Elton John in concert. And what you had to do was download an app, which was the Elton John concert app, which was a couple hundred megabytes, which you downloaded from the Play Store. You waited for that, and then you started watching. And obviously, you wouldn't watch the whole hour of concert. You would watch it for a couple of minutes max, and just, I don't know, put it away. And you'd have this app sticking around without being used, which is just sad. And also, a big problem with that is linking. How do you link inside of VR? So if you have inside your VR app, if you have a repository of I don't know, movies or elements or panoramas that you can experience, how does one link and say, hey, go to this app and watch that movie or the other movie? You can just send him a link. Which is where WebVR comes into the story. It's a way of embedding VR content. Just like WebGL is a way of showing 3D content in the browser. And since it's in the browser, it must work on different platforms. So that's Windows, on Linux, and Android, and Mac. It must work with different hardware, which means both different laptops, or different phones, or different VR headsets. And also, it must work with user consent. So one common problem is if you have a headset attached to your laptop and you're browsing, you shouldn't show the VR content immediately because it's going to go to the headset, which the user isn't currently using. So that's an important thing to keep in mind. The WebVR project was started in 2014 by Vlad Vucevic and Brandon Jones, so by Mozilla and Google at the same time. It's currently transitioning from an experimental technology to a W3C standard, and you're probably going to see it in Chrome and Firefox by the end of the year. So let's see if I can zoom in a bit. Yeah. So the way this works is you query navigator.getVR displays, which returns a promise with your displays. So you may have several VR headsets attached, and you can choose your web content can choose which one it wants to use. So what does that display give you? Well, it gives you what type of VR headset the user is using. So if it's a cardboard, or if it's an Oculus or an HTC Vive, because all of those headsets have different sensors. So with cardboard, you can only look around and see what's happening. But with the Oculus, you can also step into the content and move around the room, and you have also various other sensors you can use to control your VR experience. So you have position. Oh yeah. So every VR headset gives your content a position, so which way you're using, an orientation, a field of view, because it might be it kind of depends on the quality of the VR headset, and various other parameters which you need to use when you're displaying VR content to your users. Now, I don't know what you do when you're building apps, but you might think it's a bit cumbersome to, you need a VR polyfill to make sure that that it still works in case the user doesn't have a VR-enabled browser. Then you need to set up the camera, and then you need to set up the UI so the user can choose to go into the VR mode and initialize the scene and add lighting and make all those things that make a VR scene work, which is basically math. So no one wants to do that amount of math just to start up a project which basically doesn't do anything yet. So this is where A-Frame comes into the picture. A-Frame is a framework which web developers can use to create a VR scene. So it basically takes care of all these boilerplate code that you previously needed to work with, and it takes care of those. And then you just need to tell, you just need HTML markup to say what you want inside of your VR scene. So I want a cube, I want a sphere, I want a cylinder, and it looks something like this. So this is a very easy scene, and all I needed to add was like four lines of HTML markup, so no JavaScript, right? Okay. So the way A-Frame works, you have three things. You have the entity, which is basically a cube or a sphere or something. And then you have, so these don't do anything. And then you have components, which are reusable properties you can apply onto the entities. So one entity is a cube. It has a color and the material. And the way the lighting works, and some other properties like what happens when your sphere hits the cube. Like it could explode, or it could fall down, or something else like that. And the system, which provides a global scope services you can use to create new components, or I don't know, do lots of other things. So here we basically, that's how it works. You have a geometry for your entity, so you say, okay, it's a sphere, and then you have a material. You say, okay, this is the color of it, and so on. The cool thing about the A-Frame is that you can really mix these components around. So I can say, okay, this is a red object, so it has the color red. And this is a blue, and it has the color blue, and the cube. So you can then say a red cube, and it will just work. If you say a red big cube, and you can have like a red big cube, and you can just chain these components and just have build a really cool scene and complicated scene with not a huge amount of code, and the code is very reusable. So you could say I want a cube that is red blue, and only the last properties will be applied. So it basically overrides previously applied properties. So now I've told you about. Actually, we kind of have some time for this, so I can show you more things you can do with A-Frame. So this is a 360 video, and the code for this is extremely simple. You just add a video tag with the 360 video, and then you just apply it to a sphere that is all around you. And you'll have a 360 sphere that really works. And then you can have them be interactive. So what I have here is a cube, and it has an event. When I go over it, it transforms into a bigger one. And also notice like the shadow is changing. Yeah. And this is the code for it. So absolutely no JavaScript. Let's see. Yeah. So you have an orange cube that will have this position, and this size, and this color. So, and when you do mouse enter, the color turns to the other one, and also the shadow size changes. And then this is what we do when the cursor exits that cube. So yeah, this is pretty cool. So now this is very important when working with VR. You should only use it when appropriate. So you're going to see everything could have a VR mode, from AAA games to really simple 3D panoramas. And if you're doing a AAA game, you probably don't want to use WebVR because you want to be able to control everything in the user experience. But everything else between AAA games and 3D panoramas can probably use WebVR with big success. Now, you should also think if VR makes your user experience better. If all you have is text on your website, does it make sense to have a VR experience for text? Who wants to read text that is 3D? And that's not good. You do? Okay. Then you should think about progressive web apps. So make sure you don't keep users out if they don't have a device that supports VR. Just do progressive web apps and feature detection. If it has VR, then allow the user to use VR. If not, then just show him basically what I'm showing you here. Like this is 2D, obviously, and it's on a screen. So yeah, as I said, make it opt-in, not opt-out. So if the user doesn't want to use VR and he doesn't want to put his VR headset on, don't make him, because users don't like to be forced to do stuff. So basically, yeah, make VR the cherry on the cake. Make your content so good that users want to experience the immersive VR world with your content. Oops. Yep. So, what is the future of WebVR? I think games are going to be the biggest thing for WebVR. We have asm.js and Web Assembly, which some of you may know about and some of you might not. This is a way of making your code run very, very fast in the browser. So you can have a Unity game that you write in C++, and then you just transpile it to JavaScript. And that JavaScript runs really, really fast, and you can provide 3D environments and 3D games which the users will love. Immersive navigation. So basically, you want the user to have the option of experiencing anything in VR. So yeah. And also, I want to draw attention to the Gamepad API, which is really cool. So this has existed in browsers for, I think, a year or two already. So you can just hook up a controller to your laptop, like a 360 gamepad, and then just use that in your games or your experience to have the user navigate around in your VR if the headset won't allow him to. So these are the places you could go to learn more about this. There's aframe.io, which has a ton of really cool examples. The community has created some libraries. So if you want to have rain in your app, or if you want to have a fully functioning human, or if you want to, I don't know, animals or such, or other constructs, those are built with A-Frame, and you can add them to your VR app with just one line of HTML. Then you can go to webvr.info or mozvr.com and see lots of VR examples from both Mozilla, Chrome, or regular web devs out there. So I'd like to thank you. Please, if you have any questions, please email me or ping me on Twitter, and go play around with WebVR and see what happens. Yeah. Thank you.
Cool. We have a few more minutes left, so has anybody got any questions? Oh, here at the front.
Yep.
You're always relying on your friends.
When's actually going into production in the browser, actually?
So at the moment, you could use a polyfill. So your browser can, so your app can be VR ready before it's supported in the major browsers. But at the moment, as I said, it's transitioning to a spec, so it's currently being implemented. By the end of the year, it will be in both release Firefox and Chrome, and also Samsung has a VR browser that they recommend using with the Samsung Gear VR. Any other questions?
No, I think that's it.
Okay.
Thank you very much.
Thank you.
Okay, that was it